Hi everyone, Tara here. Welcome back to my channel. This is going to be another TryHackMe room walkthrough, of course. I'm getting up to about almost halfway through the Attacking and Defending AWS learning path. I'm a huge AWS person if you haven't seen some of the previous videos. So I love AWS. I work in the field of cloud security and I've been playing through this learning path, having a really good time and learning some new things as well. So that's good, of course. And this room is the IAM Credentials room. I actually just finished it and then I'm recording this intro after finishing it. I thought it was a good room. It talks about long-term AWS credentials, long-term access keys, and short-term session keys, and helps you get really familiar working with those. So with that little preamble, let's travel back in time and I'll show you my walkthrough of the room. This is the IAM Credentials room, and the room description says, learn how IAM handles credentials for authentication to AWS APIs. So remember, anytime we do anything in AWS, we're really interacting with the AWS APIs to do actions. Task 1 says, Introduction to IAM Authentication. Every call to AWS is authenticated in some form. For the API, this is typically done through request signing. However, when using the AWS console, you log in using a more traditional username and password combination. In this room, we will dive into the various ways you authenticate to AWS and best practices for securing your AWS accounts and passwords. So let's just follow this link really quick. Looks like this links to some AWS documentation about request signing, what request signing is, how signatures are formed in AWS. And one of the interesting parts of this documentation is the why requests are signed section. So this is describing request signing has a few different purposes. It helps verify the identity of the requester. So authenticated requests require a signature that you create using your credentials, and that helps verify that you are who you say you are. Request signing helps protect data in transit because it helps to prevent with somebody tampering with your request while it's in transit. It ensures data integrity essentially. And then lastly, request signing helps protect against potential replay attacks. So the request has to reach AWS within 5 minutes of the timestamp on the request. And if that request is older than 5 minutes, AWS will deny the request. So that would stop a bad actor from capturing your request and then replaying it, sending it to the AWS API again. If it's older than 5 minutes, the AWS API is just going to deny the request. And there's a lot of other stuff here, especially if you're really into cloud security, but we'll go back over to TryHackMe. And this is a task with no answer or no flag. We just say completed to say we read the material and we can move on to task 2. All right. So task 2 is this same accessing the environment task we've seen before. If you've watched any of the other walkthroughs of this room or if you're playing along. So there's not anything we need to do here. We just need to ensure that we know how to access the AWS sandbox environment. And if you want to see me actually walk through how this works, the video where I really go through all of this is the introduction to IAM room video. So you can see that on my channel if you need more detailed instructions of what's going on here. But for me, I can scroll up and click cloud details here and I can see my environment is still active from the last time I was using it. And my environment is ready for playthrough for all of these following rooms, including, let's see, the room we are in is the IAM credentials room. So we're ready to go. I'm just going to hit completed and move on to task 3. Task 3 is called root password. And let's see what's going on here. The first set of credentials we will discuss is the most powerful, the login password for the root account. This is the password you create when signing up as an AWS customer for the first time. There are very few limits on what the root user can do. So this password should be secured. Protect at all costs. Put it on the protect list at all costs. If your AWS account was created before 2017, this password is also your Amazon retail password. So be careful when sharing your Amazon retail password with family and friends. Although I'm sure probably if you have an old account like that, you could change the password, I assume, but I guess I don't know. If you use AWS organizations and create the AWS account via the Create Account API call, then the root password is a randomly generated string. AWS doesn't return that password when an account is created via AWS organizations. To log in as root, you will need to do a password reset. Interesting. I don't think I knew that. To log in as root or reset the password, you must use the main AWS sign-in page. And there's a link to the AWS sign-in page, which looks like what's in these screenshots here. To log in there, when you go to the sign-in page, you will be prompted to log in as an IAM user or a root user. And again, like I said, here's screenshots, and I think it's showing an example of how you could reset the password if you have a new account you created in your organization, you don't know the password. All right, and then another easy one here. So now we're just certify that you are not a robot. I'm not a robot that I know of. So I'm going to hit completed and cruising right through here. Now we are on to task 4. Task 4 is called IAM login profile. The login profile is the AWS term for a user's console password. Not all IAM users have access to the AWS console. The AWS console uses the term console password, while AWS CLI and AWS APIs are using the term login profile. So you could create IAM users in your AWS account that don't have a user password to log into the GUI, to log into the console, but they could still have a login profile that they could use to run commands from the terminal or to do things programmatically with the AWS API. To grant an IAM user access via the AWS console, you can do it from the user's security credentials tab or via the AWS CLI. And let's open this link to the console. And so here's our TryHackMe IAM user in the TryHackMe Cloud Sandbox. And here's security credentials. Here we could enable console access. So this would give this user the username and password to sign into the AWS console. And then here's where we manage the programmatic access keys they can use with the CLI or the API. Right now, this TryHackMe IAM user looks like would not be able to sign into the console. We would need to enable console access for them. Okay. And here's a screenshot. It doesn't match exactly what we saw. I think it's a little bit older, but you get the idea. All right. And then from the CLI, we can create a login profile using AWS IAM create login profile. And then we can send the user and an initial password as arguments to create their login profile. And we can also use the command line to change the user's password. So we could do AWS IAM update login profile, and we could use that to update the user password. Next, AWS allows an account administrator to set a rudimentary password complexity policy, and you will find the setting in IAM under account settings or via the CLI with this command, AWS IAM get account password policy, and we can see if we've created some sort of password requirement. So let's go ahead and run that command. Here's my local terminal that I like to be stubborn and use. But remember, if you're following along playing this room yourself in TryHackMe, you could use the TryHackMe attack box, or you could use Cloud Shell and AWS to run these commands. But I like to do it locally for the most part. So we can do AWS IAM get account password policy. And I'm going to use the profile flag to authenticate with the CLI. So let's see what we get here. All right, so we've got this error. An error occurred, no such entity when calling the get account password policy operation. The password policy with the domain name, and this is the AWS account number here, cannot be found. So this would suggest no custom password policy has been created in my TryHackMe AWS account. We're just using that default AWS password policy when passwords are being created for users. And I wonder if we can also see that here in the console. So I think under IAM, we can go to account settings and we can see the password policy. So that's under IAM, account settings, password policy. And we can see right here, this AWS account uses the following default password policy. So we haven't created anything special, but we could if we wanted to. All right. And then here's a screenshot kind of this similar thing. So here's the question. What is the minimum number of numbers required in the password policy? Okay, the minimum number of numbers. And this is a screenshot of the password policy, the default password policy. And I think it looks like the same as this one in the console. So the password minimum length is 8 characters, but we want to know the minimum number of numbers. It's like a tongue twister already. So password strength include a minimum of 3 of the following mix of character types: uppercase, lowercase, numbers, non-alphanumeric characters. All right, so I'm going to try 3. Oh, okay, it's not 3. So what did I miss here? And I'll just make sure I'll just use this screenshot as well, make sure I'm doing this right. All right, so this AWS account uses the following default password policy: 8 characters, but that wouldn't mean 8 numbers. Include a minimum of 3 of the, I get it. Okay, so include a minimum of 3 of the following mix of character types: uppercase, lowercase, numbers, and like punctuation. I can't think what the word for these is. But anyway, all right, so this is kind of like tricky, but I think the answer here is 0. Well, at least it tricked me. Maybe it's not tricky for people who are paying attention. But anyway, so include a minimum of 3 of the following mix of character types. So we need a minimum of three of these things. So if we had 3 uppercase letters, 3 lowercase letters, and 3 symbols, then we could technically have 0 numbers. So I bet the answer is 0. All right, let's try that. Okay, they got me with that one. All right, awesome. So that is the answer for task 4. And that's helping us just learn about the default password policy and also the functionality that we could create our own complexity policy for passwords for our IAM users if we wanted to. And with that, I'll move on to task 5. Task 5 is called AWS API Access Key. AWS access keys are the primary method of interacting with the AWS API. And remember, as we've kind of learned about like through these rooms, anytime we do anything in the cloud, anytime we do anything in the AWS, we're really just interacting with an API. And even the AWS console uses access keys on the back end. You'll be able to see this when we dive into our room on CloudTrail. Cool. There are 2 types of access keys: long-term access keys and temporary session keys. Long-term access keys begin with the string AKIA. They do not expire, but it's best practice to rotate them regularly. I would argue it's best practice not to use long-term access keys at all unless you absolutely can't avoid it. But yeah, if you can't avoid using the long-term access key, then you definitely want to be rotating it as frequently as possible. And then long-term keys consist of an access key ID and a secret access key. Only IAM users or the root user can have long-term access keys. However, best practice is to never generate access keys for the root user. The root user or an IAM user can have 2 access keys at one time. So at any given time, an IAM user could only have 2 active access keys. So just as an example, let's see, we can come back to our TryHackMe AWS sandbox here. And if we go to our IAM users and we know the TryHackMe IAM user has access keys because we saw those a minute ago. So if we were to scroll down, this is one way you could see how many access keys your user has. And you can see there's 2 access keys here. One of those keys is active and one of those keys is inactive. And we can see here we don't have the option to create another access key. I don't know how well you can tell in the recording, but this create access key button is faded out. And you cannot set the access key ID or secret access key. Those values will always just be generated by AWS. You can't use like a string that you want to use. All right, and long-term access keys can be active or inactive. So we just saw that example, right? So here's the active key, here's the inactive key. You can disable an AWS access key via this command. So we can do AWS IAM update access key. We give the access key ID and we can change the status to inactive. And that would disable an active key. And then we could re-enable the key if we wanted using the same command, but we'll just send the status flag and then active. And we can also delete an access key from the command line using AWS IAM delete access key. So one thing I could think of here in the real world where you might want to do this flow would be, all right, let's say you're seeing some sort of suspicious behavior or something, and you think that an access key has been compromised or leaked, or somebody has access to it that shouldn't, and they're doing something bad. You can immediately disable the access key. You can move the status to inactive, and then nobody will be able to use it to do anything anymore in the environment. And you could very easily automate this, right? Like if some threshold is reached or something, the key automatically gets disabled. But maybe you don't want to go right to deleting the key because you want to have it there for the purpose of some sort of investigation or so, auditing purpose, something like that. Anyway, you can keep it in a disabled state. You can re-enable it if you need to. And then when you're sure you don't need it anymore, you can delete the access key. And it's good to understand these different states that an access key can be in. And the other thing is, I can't really think of a situation in which you couldn't just replace one long-term access key with another as long as it's scoped to the same permissions. And this bit's important too. Once deleted, a long-term access key cannot be recreated. So once it's deleted, it's gone. That's another reason it's good to maybe go to that disabled state first, make sure that nothing has been broken once you disabled the key, and then you can delete the key. Session keys have an expiration date after which they are no longer valid. Session keys also have an access key ID and a secret access key, but they also have a long session token. So now that we're talking about session keys, we're talking about temporary access keys, short-term credentials, and this is definitely the preferable route to go. This is what I do in all my personal AWS environments that I own. I have a couple videos about it on my channel if you're interested in, but I really try only to use session keys when I interact with AWS because a lot of research around cloud security shows long-term access keys are just like they're one of the biggest problems. They are the root cause behind a lot of data breaches in the cloud. They're part of a lot of attack paths. If you can avoid the long-term access keys, I know this is like the fifth time I've said it now, so I apologize. But really, avoiding long-term access keys is the way to go, and it's getting easier and easier to do that because of session keys. So session key IDs, we can differentiate a session key from a long-term access key right away because session key IDs begin with the prefix ASIA. Remember, the long-term access keys use the AKIA prefix, and session uses ASIA. And they're temporary AWS session keys. They can't be deleted or disabled like the long-term keys. They simply just expire at the end of their session. IAM has many different identifiers, which are documented here. Oh, okay, cool. So they're by identifier, they are referencing like the AKA and the ASIA that we just talked about. So you can scroll down and there is a really nice table that helps you understand all the different prefixes in IAM. And this is definitely a great resource to review. So like we say AKIA, when we see that, we know we're dealing with a long-term access key. If we see an ID that starts with AIDA, we know we're dealing with an IAM user. So these prefixes are really useful. All right, and as always, back to what I'm supposed to be doing. Long-term credentials can be created via the AWS console or the AWS CLI. So we can create an access key using AWS IAM create access key, and then we just target a specific IAM user. And short-term keys are only provided when requested, and there are numerous ways AWS can provide those. They are generated by the AWS Security Token Service, which is abbreviated to STS. The most basic way to generate the short-term keys is AWS STS get session token. And I believe we're going to be learning a lot more about this down the road in this learning path as well. All right, so how many active IAM access keys does the TryHackMe user have? Well, we just saw that. I think it was one, right? So let's see. So we are in our TryHackMe IAM user. And just in case we need to like start over here. So we could go to IAM, the IAM service in AWS, and we can go to users, and then we select our TryHackMe IAM user, and we can scroll down. Oh, excuse me. And we can go to security credentials, and we can scroll down, and we will see that we have the two access keys right here, and one of them is active, like we said before, and one is inactive. So therefore, I think this is less tricky than task 4, hopefully, unless I'm missing something. And I think the answer is 1. Okay, whoop, whoop. So that was correct for task 5. And now we'll move on to task 6. Task 6 is called MFA in AWS and best practices around credentials. AWS supports using a virtual MFA, and I think this stands for like time limited one time password or something like that, TOTP, and hardware token or UTF security keys. So you could use any of those 3 things for MFA. Probably virtual MFA is the most common choice. MFA can be applied to either an IAM user or the root user. When using an identity federation to assume an IAM role, implementing MFA is the responsibility of the identity provider. So if you're federating into AWS using some sort of identity from somewhere else, you would do the MFA part when you are authenticating with the external identity provider rather than in AWS. When MFA is applied to an IAM user or the root user, AWS will require the second factor when performing a console login. MFA is not required by default when making an AWS API call using access keys. However, IAM policies can implement conditions. Remember, we saw this before if you saw the other permissions room where we were using the conditions block in IAM policies. You can implement conditions in your IAM policies that require MFA for certain actions. To do this, the user must first request temporary credentials and pass the MFA token as part of the request. The new temporary credentials will have a flag that says MFA was present when they were created, and the IAM policy condition will then be satisfied and the action will be allowed. Mishandling of AWS credentials is the primary way an AWS account is compromised. There are several best practices for handling AWS access keys that you should follow. Avoid using IAM users whenever possible. Sing it from the rooftops. This is like so true. If you can do this, this is a really good step in the right direction. Avoid using IAM users whenever possible. Many cloud providers offer the ability to use SAML or OIDC to get session credentials for AWS API access. Session credentials are just so much better because of the time limited aspect rather than long-term access keys attached to an IAM user. Never commit an access key to a source code repository such as GitHub or GitLab. GitHub will scan all commits to public repositories for any of the AKIA prefix that denotes a long-term access key. And if GitHub finds that, GitHub notifies AWS, and AWS will promptly disable that key for you. But even committing access keys to a private repository is very bad because that repository could be compromised, and attackers will look right away for AKIA in the source code or in configuration files. And this is like a problem or risk easily mitigated by automation. Even like the savviest AWS security people I know, everyone can be guilty every once in a while of accidentally committing something they shouldn't. So get automated scanning somehow in your CI/CD process, even for like personal projects and stuff. Make sure you are somehow checking programmatically for access keys in your commits. It will save you a lot of heartache down the road. And maybe I'll make a video about how I do this in my own personal repositories and post it to the channel. So if I ever do that, I'll update the description below to link this, but let's see how industrious I get. Anyway, um, the third best practice here, rotate access keys often. So yeah, if you have to use access keys, make sure and rotate them. When you create the access key, you have the option to download the credentials as a CSV file. These CSV files collect in your downloads folders. And if you don't properly clean those files, uh, if you just leave them sitting in your downloads file, that's a risk where they could get compromised from there, from the downloads folder in your local machine. They use like an example here of if the laptop is left in a taxi cab, the credentials could find themselves for sale on the dark web. So yeah, just you don't want to leave those CSV files lying around. And then lastly, use multi-factor authentication for access to the root and IAM users. Use multi-factor authentication everywhere you can use it. Many of the IAM identifiers can be useful from a reconnaissance perspective. For example, we know to look for AKIA strings, and while they are not sensitive, they can be used to identify an AWS account with the following command. Okay, cool. So let's try this command with the access key in this TryHackMe account, and let's see a demonstration of this. So AWS STS get access key, was it info? Get access key info, and then we can, why am I not just copying and pasting this? All right. So silly me. And then so we send the access key ID. We can get that from here. So you can see they both start with AKIA. Let's get the one that's active. And and then this is just to be authenticated with the CLI. Let's see what we get. Mhm. Okay, so we can send the access key ID and it returns the AWS account ID where that access key is. So you can see why that might be helpful for reconnaissance on an account. Okay, so we've got two questions here. First is which user has an MFA attached to it? So MFA being multi-factor authentication. So to answer that, I'm sure we could do it with the command line. We can also just go over to the AWS console and I'm going to go back to the console home just so we can see like from the beginning how we would go about doing this. So first we can navigate to the IAM service. So we can click right here because we have been using it all day, or we can just search up here for IAM. And then let's see, we can scroll down and we want to find I think it was we want to figure out which user has MFA. All right, so we've got two users here. And I think we can actually even tell just right from this list, right? So we've got MFA right here. And we can see that the TryHackMe IAM user is the one that has MFA. We could also see this by clicking into the user, and then we can go to security credentials, and you can scroll down here to see the multi-factor authentication configuration and update it. So for our user that doesn't have MFA, for example, which is this user, the console access enabled without MFA gives us like a nice warning right there. And then under security credentials for them, we can see they don't have MFA, and here's where we could set it up. All right, so anyway, let's see. So all of that random like blabbing to say what was the name? The name was TryHackMe IAM user. Let's try that. Okay, whoop whoop. So that was the first question. And another way we could have answered this, so I know which user I am when I log into my TryHackMe sandbox, and we know there are only two users in the account currently in this module that we're in. So I know that this user does not have MFA applied because when I log in to the console, as that user, I don't have to use MFA to do it. So that's another way we could have answered that question. All right. And then the next question is, what account ID does this AKIA key belong to? So we just practiced doing that actually, so we can do it again. Let's run the same command. However, we'll use this access key ID instead. All right. I'm going to laugh so hard if that's the exact same access key ID, but it's okay. So let's see what account this access key belongs to. All right. And this belongs to this account. And I think we've seen this account number before. So let's give that a try. And there we go. So that is task 6. And we are almost done with this room. Just one task to go. Task 7 is called How Services Get Credentials. As we noted in the section on IAM roles, AWS services can also leverage temporary credentials to access resources in your account. The role's assume role trust document must specify the service as a principal allowed to assume the role. And I think we've seen examples of this before. For example, I'm remembering we looked at one trust policy that I think had the events service as a principal allowed to assume the role. The mechanics for getting those credentials vary depending on the service, but when you're attacking or defending cloud infrastructure, knowing how to get these credentials is vital. The primary way to get credentials for a role is with the AWS STS Assume Role API call or AWS STS Assume Role AWS CLI command. If you're using an EC2 instance, there is a special network address in the hypervisor you can use to request temporary credentials for the EC2 instance profile. It was through this instance metadata service, IMDS, that the Capital One breach was executed. We talked about this in one of the earlier rooms. I want to say maybe like basic concepts, instance metadata service, and how IMDS was part of the attack path for the famous Capital One breach. And you always want to make sure you are using IMDS version 2 in EC2. IMDS version 1 is not good, it's vulnerable. In a future room, we're going to show, okay. In a future room, we're going to practice using IMDS. So we're going to do a curl to the IMDS address and it'll give us back temporary AWS access keys. Oh, I'm always jumping the gun. Okay, apologies. As a response to the Capital One incident and outcry from the cloud security community, AWS released the IDMS version 2. I think this is a little error there. So I think they mean IMDS. Now I'm confused because it's instance metadata service. So I think this is just flipped right here. So it should be IMDS version 2. Let me double check if that's right. Yeah, okay. So we've been saying it right the whole time. IMDS version 2, which requires a two-step session-based method. So just to say that again, because those two letters being swapped threw me off. As a response to the Capital One incident and outcry from the cloud security community, AWS released the IMDS version 2, which requires a two-step session-based method, which is better and addresses that vulnerability in IMDS, the first version that was wreaking havoc. If your code is running in AWS Lambda, which is the serverless compute service, the access key ID, secret access key, and session token are available as environment variables in your Lambda environment. For ECS containers, ECS is a Elastic Container Service. There is another IP address you can curl for the container's credentials. And hopefully, I wonder if we're going to practice using this later. But we can curl this address, and the AWS container credentials relative URI environment variable will be populated if the IAM role for the task is configured. If you've never used ECS, just know from within your container, you could curl this address and it would return credentials. Finally, you can get temporary credentials from your Cloud Shell with this simple command. All right, so let's actually open Cloud Shell. We haven't done that yet. And let's see what's going on in Cloud Shell, which is the browser-based terminal where you can run commands with the CLI, and probably what I should have been doing all along rather than being stubborn and setting up my local profile. But what can I say? I am who I am. All right, so let's try using this command. So from within Cloud Shell, you can run this command, and let's see if it returns credentials. Okay, indeed. So we can see this is returning access key ID, secret access key, and I'm going to blur these out, even though I can see these are temporary credentials because they have an expiration. But who knows, maybe I'll actually be really fast editing this video and you'll have time to hack me because they don't expire until tomorrow. So who knows what I'll get up to. But anyway, Use the Cloud Shell and curl command above to download the temporary credentials. What is the JSON key that begins with E? All right. So that's the expiration key. If you're not familiar with JSON, in JSON, there's keys and values. So this is a key, the expiration is a key, and then the time it expires is a value. So they're asking the key that starts with E, which is expiration. And then when using temporary credentials, what are the first four letters of the access key ID? So when using temporary credentials, I believe that was ASIA as opposed to AKIA, which I said so many times, like a tongue twister. All right, awesome. So that was our IAM credentials room. I thought that was another good one. And I'm going to take a break, grab a drink, and then I'm going to go on and play the next room, which is the quest for least privilege. So maybe I'll see you there. And thank you for watching.